Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Halloween Sudoku by Rice-Smith. And as you can tell, I'm a little bit behind in doing these puzzles, about a month behind or so. So I'm going to be it's inevitably, I don't know, unless I do fewer of the puzzles that I do enjoy, it takes a while for me to catch up to some of these puzzles. Anyways, also this puzzle does not have the color coding that I put in. It does not, and this is actually pretty important. Once we get through all the rules, I'll basically give you guys essentially show you where to. I guess I'll put a link to the original post so that you can see yourself where the different objects have to be. But I've also got it here marked down, and I'll describe each one as I get to it in the rule set. So let's just get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have to draw a path through the cemetery from the ghost, which is marked here, to the pumpkin, that moves only orthogonally, which means just to the left and the right or up and down, and doesn't touch itself, not even diagonally. So we need to go from the ghost to the pumpkin in some path, which moves in some diagonal method. So this would be a valid path here. And again, this is the ghost positioning, this is the pumpkin. It cannot touch itself diagonally, so you could not do something like this, adding in a small little hump here. And you cannot touch itself even diagonally, so you couldn't do something like, say, this. This would not be allowed, because it would be touching itself diagonally. So the path has to go, the ghost must enter each box one time. Well, does that include box 1? Because it doesn't enter it here. That's interesting. Huh. Yeah, there's a lot of question marks here, but supposedly the ghost must enter each box one time. So this actually, even if we tried this would not technically be valid because it's not entering box 1. But I wonder if that's an oversight or if that's basically expected. Huh. I don't know. Huh. Okay. There's a lot of problems with this. So for one issue is that the actual headstones and ghost and pumpkin and vampire do not show up on this puzzle. So you have to translate it here, which is fine, but huh. Anyways, burial plots that is non-overlapping 1x4 I tetrominoes are placed around the cemetery, and each burial plot has a headstone at one end. Yeah, there's no way that you can be entering box 1 without touching itself. Because headstones mark the end of a 1x4 tetromino. So, for example, this could be a tetromino going that way or a tetromino going that way, which just means four cells all as an eye. So all in a row. So the eye could be here, there could be an eye here, and the pink cells I marked are all headstones. So could be one here, this could be one here. This cannot go here because oh, it does not. Does it say? Yeah, non-overlapping. So they cannot overlap. So if you try to go this way, has a headstone at one end. So this cannot be a tetromino going this way. Because if it were, this would not satisfy the headstone at one end, and it would be overlapping with another tetromino, right? Or line, essentially. Each burial plot has a headstone at one end, and the path may not enter any cell that is part of a burial plot. So say we had a tetromino here. The path could not enter here at all. So cannot enter any space that has a headstone, obviously, because the headstones, each burial plot has a headstone at one end, and these pink cells are the headstones. As you can see, so this is essentially the original, and this is the translated one that I have. So you can use that as a translation. The ghost must enter each box one time. I guess it counts as entering box one by just being here. Each headstone, so all of the headstones, contain the number of path cells in the surrounding cells, both orthogonal and diagonal. So this cell would say how many path cells are in the 5 surrounding cells around it, because obviously the ghost cannot go into the headstone or near any burial plot, right? So same with this cell, it would say how many of the path cells are in the surrounding 8 cells around it. And that's orthogonal and diagonal, so basically the 8 surrounding cells, up to 8 surrounding cells. The vampire is part of a burial plot, but it's not a headstone. So this is the vampire that I marked in red. The pinks are the headstones, the vampire is in red. The pumpkin is the orange P, the ghost is the green G. So the vampire is part of a burial plot, but is not a headstone, so it doesn't contain the rule set for the number of path cells around this vampire. So keep that in mind. You don't have to use that, the headstone issue. And you have XVs, where cells separated by an X sum to 10, and cells separated by a V sum to 5. Not all X's and V's are necessarily given. So, for example, if this cell were a 3, this cell would have to be 2, and this cell would have to be 7, because these two digits must add up to 5, because there's a V between them, and these two digits must add up to 10, because there's an X in between them. And those are all the rules. So I hope that was clear. So you're trying to make a path from the ghost to the pumpkin, which is the green G to the orange P. The ghost must enter each box one time. I think it's considered enter. In fact, it almost has to be. It has to be considered entered for box 1, because otherwise you're going to have problems. Each headstone, there are burial plots, which are 1x4 I tetrominos, which are placed around this grid, and they each have a headstone at one end. The path may not enter any cell that is part of a burial plot. So these are all the headstones. And the vampire is part of a burial plot. That should give you a lot of information there. So this is the vampire, these are the headstones, this is the pumpkin, and that's the ghost. And as you can tell, that maps to these cells here. There's the ghost here. Whoops. And that's going to this thing again. But there's a ghost here. These are headstones. This is a vampire here. This is a pumpkin here. And then the only thing you can't see that's covered by my head is there's a headstone down in the lower right corner where I've marked it. But I will give you the post 2 that I will give you a link to that post so that you can use it yourself just to double check that I didn't make any mistakes here. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And as I said, there's going to be a link to the original post itself because there is no actual grid with the actual things shown. So you'll have to mark them in yourself. Either way, I'm going to get started. Let's go. Oh, shoot. Dang it. Okay, I'm going to have to mark them in again. So this is the ghost. This is the pumpkin, I'm pretty sure. Yep, we have... These are headstones. This is a vampire. I think we have 3 in row 4. We do. So here, here, and here are headstones. And we have here, here, and here. Yep, are the other headstones. Well, the vampire is part of a 1x4 burial plot. It can't be this one. Can't be here because that's can only reach 4 there, so it must be part of this one. So this has to be a burial plot, which means it cannot be. These cannot be entered into. This could go this way or this way. We're not sure. So this is done. So we know this is a burial plot. This one cannot go up, cannot go down. It has to be that way. So this is a burial plot here. So this green has to go as a path, and this is why I knew you couldn't enter box 1, because you cannot go here and then enter here without touching itself. And you couldn't even exit out then. So this has to be part of the path, which means it must go this way, because it can only move horizontally or vertically, because it can only move orthogonally. Therefore, this can't be going this way. This has to go this way. So this is the burial plot this way. This can't go this way. This has to go this way. So this is burial plot this way. This can go either here or here. Technically it could go this way. Okay, it has to enter in box 3. But it could enter in here. It could enter in here. We don't know. This one could go that way. This one could go that way or that way. So this is done. Oh, we do know. Okay, so this can't be part of the path. We do know each headstone has to be at least 1. So the path has to be in one of the surrounding cells around each headstone. Well, for this one, it has to be here, which means it enters in and exits out that way, because that's the only way. Cannot touch itself, so that's not in the possible. So this has to go this way, which means it connects to here. So this is done here. Cannot touch itself, so it cannot touch itself here. This cannot go this way, so this must go this way. And because otherwise it would block the path. So this must go out this way because it can't go up, it can't go down. And obviously can't go right. So this is done. This one cannot go up, so it could go left. So that's possible. Okay. These are not going to be on the, because they're blocked off from being on the path. This has to have a path. So it has to enter in here and exit out this way. So this is not on the path then. Must exit out here. This cannot touch itself, so it would be considered touching itself here and here. This must go this way then. So this could go this way. This has to have at least... Okay, so this has one cell on the path that is touching, but this has one cell on the path that is touching. And that's a contradiction. Huh. Oh, I see. No. Huh. Okay. Well, that's a contradiction. So it cannot go this way. We just proved that. We know this one goes this way. We tried having this go this way. And that doesn't work. So it has to go this way then. So this is going this way. It does have to go this way either way. That means it has to go through here. So that means it goes this way. One of these at least has to be touching. If it goes here, it has to go through here. So it goes at least through here. This has to at least go this way because it cannot... If it tried to go around here, it would be stuck there. So this is not on the path. One of these two is. You can't just go straight here. Okay, so this... If you go straight here, again, you have this issue. Can this be going this way? Maybe. No, it can't. This needs to have... Maybe it can. Hmm. Can this be going this way is the question, right? If we have this going this way, this is 2 at most. This is 2 at most. So that would be take care of 1 and 2. This would have to have at least 3. But the thing is, if it goes, no matter which way it goes, so say it goes this way, you cannot have the path go like this because it would be considered touching itself. So this would be at most touching 2. And if it goes this way, that's still only touching 2 at most. So this is guaranteed to be 1 or 2. That means, of these, if you go this way, this would guarantee that this is 1. And I guess you could... No. I guess you could do something like that. That is possible. No, that's not possible, because this has to be the headstone of a burial plot. So it either goes here, or it goes here. Say it goes here. If it if it goes here, that means this is 1 or 2, this is 1 or 2, and this is 1 or 2. So this cannot go this way. It has to go this way. So this has to go burial plot this way. Which means this must be a burial plot this way. Which means you can never get here. So it could be burial plot that way. This is 1. This has to be 1, because that's the most you can get here on this path. This is at most, sorry, not 2. This is, again, 1, because you can have at most 1 here. This must then be 2, where it connects there, and this has to be 3, which means it must go this way. It cannot touch itself, so that can't go there. It has to go there, but we don't know which way it goes, so it has to go through here. Cannot touch itself here, so it continues there. This cannot touch itself here, or here, or here, so it must go through this way. This must dip down here at least to have 1 here, which it could, or it could be 2. So this cannot touch itself here. It cannot touch itself here. This sees 3 cells, so this is 3. This cannot be 2, so it must, or 3, so this has to be 1. So this cannot be touching here, so it has to go down this way. This is not valid here. It could go that way, going this way. This is 3, 4, or 5. We're not sure which. This must be a 1, 4 pair, because we have a 3 already in the row. So this is 1, 4 with either 6 or 9 here. This is a 1, 4 pair, which eliminates 1 and 4 in the rest of the box. So this must be 2, 3, or 7, 8 to add up to 10. This is either 1 or 2. So we have 1 or 2 with 8 or 9 here to add up to 10. You could have, again, this is 1 through 4. Next to 1 through 4 here. This can't be 1, so this can't be 4. So this has at least one cell, obviously, and at most 3 cells here that are touching it. This is 3, which forces this to be 7. This 2 eliminates 1 and 4, 2 and 3 as a possibility here, so this is 1 and 4, which forces this to be 3, which forces both of these to be 2 to add up to 5 with it. So this is 2, which eliminates 2 here, so this is 1 and 9. That means only 1 cell in the surrounding 8, or up to 8 cells, is on the path. So this is not on the path. It has to go here. That eliminates 1 here. This is 4. It cannot go down here because it would be considered touching itself. So it can't go here. So it must go to here. It must go at least 2. So it has to go at least to here. It could go all the way here. That's fine. It cannot go down here because it would be considered touching it. It can't exit out. It can't go here. So this is 2 or 3. This is 1 and 9 to add up to 10. This cannot be 1, 9, 2, 8, or 3, 7. So this is a 4, 6 pair here, which forces this to be 4 or 6 here. This cannot touch 2 or 3. So this has to be 1 itself. So this is 1, which means it cannot touch itself there. That means it touches here. It has to also touch here because it can't be just 3 here, because this is 4. It can't be 1 or 4 because of the 1, 4 pair in the box. So this is 5. This is not on the path. Oops. This is not on the path. So the path is pretty much set. This 2 eliminates 2 here, so this can't be 8. This can't be 1, 2, or 3. So this could be 2, 3, 7, 8, or 4, 6, 4, 6. Remaining digits in row 4 are 4, 5, 6, and 8. This can't be 4 because of the 1, 4 pair in the box. So this is guaranteed 4 here. This cannot be 5 here. Where is the 4 in column 6? Can't be here because of 1, 4 pair in the box. Can't be here because one of these 4s is guaranteed in this box, so 4 has to be one of these 3. Therefore, this cannot be 4 and 6 to add up to 10. So it can't be 2, 8, no 1, 9. It must be 3, 7. And this can't be 3, so this is 7, 3, and 7 here. That eliminates 3 and 7 here, so this is 2 and 8. Where is 7 in row 5? Cannot be here because of 7's in the boxes, so it has to be here. Where is 6 in row 5? Cannot be here because of the 4, 6 pair in the box, so it has to be one of these 3, which eliminates 6 in the rest of the box, which means one of these 2 has to be a 6. 8 cannot be here because of 8 in the column. 1 eliminates 1 here, so this is 4, this is 1, and it must add up to 10 with 9. This 4 eliminates 4 here, so it's 5, which means this can't be 5. This is a 6, 8 pair. This must be 4 then. We have 4 and 6 here, 4 and 6 here. Where is 2 in column 6? Can't be here because 2's in the boxes. They have to be one of these 3. Where is 1 in box 5? Can't be here or here because of 1's in the columns. Can't be here because of the 1, 4 pair in the row. So it has to be here. Remaining digits in box 4 are 5 and 9. That eliminates 5 and 9 in the rest of the row. So this cannot be 5 or 9. This is 8. Remaining digits in box 5 are 6, 8, and 9. This can't be 8, this can't be 9 because of the 8 and the 9 in the column. This can't be 9. Where is the 9 then? In row 5, it has to be here. That leaves 2, 3, and 5 remaining in row 5. This can't be 2 or 3 because of the 2, 3 pair in the column. So this is 5, which eliminates 5 here and here. Remaining digits in column 4. We have 3 and 6. 3 can't be here because of 3 in the box, so this is 6, that's 3. Remaining digits in box 2. We have 6 and 7. This 3 eliminates 3 and 7 here as a pair to add up to 10. 6, 7 as a pair eliminates 6 here, so this is 8, which makes this 6, which makes this 8. That leaves these digits as 2, 4, and 5. 2 cannot be here because of 2 in the row. This is 2, 4, which would have to add up to 6 and 8 to add up to 10. 8 cannot be here because of 8 in the column, so this is 6, this is 4, which makes this 5, which makes this not 4 or 5. That's 2, which makes this 3 and 2 here. So this sees 2 cells in the surrounding up to 8 cells, so this cannot be on the line, so it must connect here. Sorry, in the path. So this is the path here. And the rest we do with normal Sudoku. Well, maybe some of these 10 things added together. Remaining digits in column 8. We have 4, 6, 7, 8. 4, 6, 7 cannot be here. And 7 can't be in either of these spots because of the X's. So 7, where is 7 in column 8? It has to be here. That leaves this as 4, 6, or 8. 6 eliminate 6 here, so this is 4, which makes this 6, which makes that 4. This can't be 4, 6, so it's 8. This can't be 4, 8, so it's 6, which adds up with 4 to add up to 10. This 6 eliminates 6 here, so it's 7 and 6. And now we have to do just normal Sudoku in the rest of the grid. Whereas the 1 in row 7 cannot be here because 1 in the box, so it must be here. That leaves 6 and 9 remaining in the rest of row 7. We don't have very many good choices from the rest, but let's see. Remaining digits in row 2, we have 1, 2, 8, and 9. So 1, 2, 8, and 9. This can't be 2 or 1. This can't be 2. And this can't be 1. So 2, 8, and 9 here. Row 3, we have 2, 5, 6, 8. 2, 5, 6, 8, 2, 5, 6, 8, 2, 5, 6, 8. None of these can be 6. This can't be 8 here. So 6 has to be one of these two. Well, where is the 6 in box 1? It has to be in columns 2 and 3. Where's the 6 in box 4? It has to be in columns 2 and 3, which eliminates 6 from the rest of columns 2 and 3 because we have 2 6s already being used. So this cannot be 6. This is 9, which makes this 6. 9 eliminates 9 here, so this is 5 and 9. 9 eliminates 9 here, so this is 8, which eliminates 8 in the rest of the box and the row. Whereas 8 in row 3 cannot be any of these cells anymore, so it has to be here. Okay, we have this 5 can't be 5 here. This can't be 2 here. 9 cannot be 9 here. Remaining digits in column 1 are 4 and 5. 4 can't be here because of 4 in the row, so this must be 5, which makes this a 4. Remaining digits in row 9. We have 3, 7, and 8. 3 and 8 both cannot be here because of 3 and 8 in the box, so this is 7, which forces this to be 3, 8 here. 3 can't be here because 3 in the column, so this is 8. That's 3. 8 eliminates 8 here, so it's 6 and 8. 6 eliminates 6 here, so it's 5, which makes this 2, which makes this 6. 2 eliminates 2 here, so it's 3 and 2. 2 eliminates 2 here, so it's 9, which makes this 1 and 2 here. 1 eliminates 1 here, so that's 4 and 1. And the rest we can really do from Sudoku. Column 2, we have 4 and 7 remaining. 4 can't be here because 4 in the box, so it's 7. This is 4. We have 7 and 9 remaining in column 3, so this is 9, 7. In column 7, we have 5 and 9 remaining. This can't be 9 because of 9 in the row, so this is 5, 9, which leads this to be 5 and this to be a 3 in the corner. Interesting. Yeah, I mean, it flowed pretty well. The logic here was kind of interesting here. This one was basically you had to go this way, so that was interesting. I made a bad assumption here, but fortunately we were able to find it pretty quickly. So overall, it's nice. It would be nice to have the actual like symbols in the grid itself, so we didn't have to reference the puzzle page, but it is what it is. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.